Today I will solve the two cubic structure problems. First problem is gold has FCC structure and radius of a gold atom is 144 picometers, and calculate the density of gold at room temperature. So what we know is that we know that the gold has FCC structure, and FCC structures includes 4 atoms. We know the radius of the gold atom, so which is here, right? And radius is 144 picometers. And we have to know that 1 picometers equals to 10 to the minus 10 centimeter. And by the way, this was my exam question when I was an undergraduate student. And okay, this problem is easy. We have to know the length of the cube of a gold atom. And we also have to know molar mass of gold, which is not given in the problem. And we can look at it. And the molar mass of the gold atom is 196.967 gram per mole. But firstly, I want to know the A. Why? A is very important since if I know the A, I can calculate the volume of the cube. And density is equals to total mass over the volume of the cube, right? And if you look at this side of the cube, you can calculate the A. How? Firstly, if you look at that side, we have one atom here, another atom here, another atom here, and another atom here. And we have also a facial atom. Therefore, it is a FCC structure. So this side, I know this. What is this? This is R. We have another R for the central atom, another R, and another R. This side is A. This side is also A. And these two sides are perpendicular to each other. And A square plus A square equals to R square. So 2A square equals to not R, sorry, 4R. 4R square. So this is 16R square. Since hypotenuse consists of 4R, right? And I have to put numbers, but maybe I can make something simple here. So A square will be equal to 8R square. Or A will be equal to 2 square of 2R, right? And we know the R is equal, which is given in the question. R is equal to 144 picometers. And it is 10 to the minus 10 centimeters. So 1A is equal to this number. And if I want to calculate the volume of the cube, it will be A cube, right? And it will be equal to 2 times square root of 2 times 144 times 10 minus 10 cube. And I can calculate it by using a calculator. So this is equal to 6, 7, 6 times 10 to minus 23 centimeter cube. This is the volume of the cube. And the mass, we have to know the mass to calculate the density, since density is mass over the volume. We have 4 atoms. Firstly, we have to know that in FCC structure we have 4 atoms, and the mass of the FCC structure of the gold atom is, we have 4 atoms. The molar mass of the atom is this number, gram per mole, but we have to get rid of from the mole. To do that, we have to know the Avogadro's number. So if we divide the total mass with the Avogadro's number, it will give the total gram of the 4 gold atoms. And since these are will cancel each other, and I have to calculate that number. Four times and the total mass is 1.30875 times 10 to the minus 21 grams. And we can calculate the density of the atoms, density of the gold. Since we know that the density is equal to m over v, I know the m and the volume of the cube. So d is equal to m 1.308 times 10 to minus 21 gram over the volume, which is 6 times 10 to the minus 23 centimeter cube. And I can calculate that number. This is over 6.7, 6 times 10 to the minus 23, which is equal to and the unit is gram per centimeter cube. And we can check this value from the internet. If you look at the gold density, so it is pretty correct, 19.2332 gram per centimeter cube. So this was my exam question, and the main common mistake is that is done by the students is the Avogadro's number. If you forgot the Avogadro's number, you will calculate very wrong numbers, and you will lose incredible amount of points. And in second question, metallic iron crystallizes in a cubic lattice. The unit cell H is 287 picometers, and the density of the iron is 7.87 gram per centimeter cube. How many iron atoms are there within the unit cell? So we have a unit cell. We can draw the unit cell. We have something like this. We don't know how many atoms inside the unit cell, but we know A, which is 287 picometers. Or we can make it easy, 10 to the minus 10 centimeters. And I can calculate the volume. So this is the volume of our cube, and we have to calculate the mass of the cube. Right, if you don't know the structure of the cube, I will write exact steps. This might be FCC, BCC, or simple cubic, whatever. So the mass of the iron is number of iron atoms times 55 times 854 gram per mole. And actually I know this number. This is the molar mass of the iron. And we have to divide this number, Avogadro's number, again to get rid of from the mole, which is the most important step, I think. Units will cancel each other. And units will cancel each other. But I have to calculate this number. I don't know this. And we can calculate, hopefully, 5. And this number is equal to 5.278 times 10 to the minus 23. So mass of the iron is number of iron atoms times 927 times 10 to the minus 23 grams. And don't forget the unit of this is gram. So we are making the right thing right now. And we also know that mass is volume times density. In our case, we know the volume, which is this number. I can show this is the volume, and we know the density. So actually, we can easily calculate this number. So to do that, we have to multiply density of the iron, which is this number, and our calculated number, 236. Centimeter cubes will cancel each other, and I can calculate this number also. So this number is equal to 1.857 times 10 to the minus 22 grams. So this belongs to here, and we can write the equation again. Number of iron atoms times 927 times minus 3 grams, and as you see, grams will cancel each other, and I will divide this number to this number. I can clean it. 9.27 times 10 minus 23. In this case, I can delete here. We also delete this thing. And as you see here, minus 23 cancels here and it becomes 10. So this part will be approximately 18 and this part is approximately 9. So we have two iron atoms inside the cubic cell. So this is the answer. So this might be a BCC structure, since BCC structures contain two atoms. And if you didn't watch the previous video, you can watch now. And thank you for your attention. This kind of questions will be your exam question if you are taking a general chemistry course or material science course. It was a question for me at least.